right, we're continuing 5.2. So if you're not here, please get here. We went over how to switch between log and exponential form. Okay, so just showing you again how to switch in between these. I have my base. I like to write it as, if it's in logarithmic form, I have g log base a of x equals y. I normally like to write it this way because then when I'm solving it, I circle my base and I'm switching the order of my x and my y. So it's going to look something like a to the power of y equals x. Okay, so that's what we did before. You guys took a quiz on this. You're just switching the order, just rearranging it. These are properties of logs. Okay, these, I'm not saying you have to memorize it. It is easier if you memorize it to just get your answer. But when you're looking at these, you're trying to find answers. So in this lesson, in this section of the lesson, what we're doing is we are solving for x. Okay, we're solving for an x. So using the properties, it's easier for us to find that. But knowing the properties isn't required. You can always solve for something that's missing, but again, it is in your best interest to know this just to make it easier. And once you see it in the examples, it'll make more sense for some of you guys. All right, so let me explain some of these. Log base a of 1 equals 0 because a to the power of 0 equals 1. So anything, whenever I have a base here, it could be 4, it could be 8. If I have log base 8 of 1 equals 0, because if I have any number to the power of 0, we should know it equals 1. So that's something that we should know automatically. Keep in mind, if you were to switch the order of this, this is what I get. So here's my base, and I'm switching the other two. My base stays the same. It now has a power of 0, and it equals 1. Again, if I wanted to switch this with a number, okay, if I wanted to give it a number, like I said, 8. So let's just say I have log base 8 of 1 equals 0. I'm going to have 8 to the power of 0 equals 1, which is a true statement. Okay, so again, once you see these properties, that's pretty easy to solve, or you could just switch the order and find it yourself. Now, looking at number 2, okay, log base a of a equals 1 because a to the power of 1 equals a. Again, plug in a number. A is any number. So here is my base. And again, all I'm doing is switching the order. So let's say I have log base 4 of 4 equals 1. Switching my order, 4 to the power of 1 equals 4, which is a true statement. Okay, 4 is my base. My base is still 4. Looking at number 3, same thing here. All right, log base a, this is my base, and I'm still switching the order. So my base is staying the same. I have a to the power of x equals ax. Keep in mind, how did we solve it last time? You could cancel these out. Okay, cancel my bases out. So in this case, anytime you see your base with the log with the same base, these cancel out and you're still going to have the same thing. Okay, or you could switch the order around. Here is my, showing you this one. Let me erase this to just give myself some space. This is an exponential form. Okay, this is an exponential form. This is my base. This is my exponent. This is my answer. This is an exponential form. I can switch it to logarithmic form. So I'm going to have log base a of x. Remember, I'm switching this order. Equals log base a of x. These could cancel out, and I'm just going to get x equals x. And for that one, once you see in the examples, it'll make more sense. But again, this one right here is an exponential form. I changed it to logarithmic form. Okay, This is an exponential form. This is my base. This is my exponent. This was my answer. And I'm still switching the order like I've been doing. Looking at number 4. Okay, we covered something like this in the last few lessons. These are the same. This is the same thing as saying, okay, a to the power of x equals a to the power of y. My bases are the same, so I'm going to have x equals y. And again, once you see it with numbers and examples and you practice it more, these would make a lot more sense. But these are the properties, okay? These are the properties for you to know just to get your answer a little bit more quickly. All right, looking at these examples, this is not going to take long because we have seen these before. For these questions, we are solving for x. How are we solving for x? Same thing we did before. However, I am not using log. Okay, I'm not going to use log. I'm going to change my logarithmic form to exponential form. Okay, I'm going to change these log equations to exponential equations, and then I'm going to solve for x. So switching the order, here's my base. I'm switching these. My base stays the same. My exponent is now x equals 32. You guys did these. Again, we've done these. What do I have to do for this question to solve for x? I have to try and find the same base. And in this case, I'm going to use 2 as my base. So this stays the same. How am I changing 32? With a base of 2. 2 to the power of what gives me 32? 2 to the power of 5 gives me 32. All right, cancel out these bases, and I'm going to get my answer, x equals 5. Super easy, stuff we've already done. We should know how to do these. That is all you have to do to solve for x for these questions. Looking at number 8, same thing. I don't want to use log. I'm going to change it to exponential, okay? Changing it to an exponential equation. So taking that base, switching these two orders, I'm going to have 4 to the power of x equals 2. Have to try and get the same base. So in this case, I'm going to change this base to 2. So I'm going to have 2 to the power of 2 times x equals 2 to the power of 1. Remember, if there's no exponent, it's always a power of 1. Cancel out my bases, and I'm just solving for x. 2x equals 1. Divide by 2, it's just algebra from here. And x equals 1/2. Super easy, nothing too hard. Looking at number 9, same thing. Okay, changing it to an exponential equation. Keep in mind, this one was a property. This one was a property on the other slide. Okay, this one was a property. But let's say we didn't know the property, I'm still doing the same thing. Here's my base. Switching my order, I'm going to have 3 to the power of x equals 1. Property was log base a meaning any number. Let me go ahead and change that to an a. Log base a of 1 equals 0. This is my property. So what does that mean? Any number that's down here, if it has something times 1, log base a of 1 is going to equal 0. 3 to the power of what equals 0? I'm sorry, 3 to the power of what equals 1? We should know anything to the power of 0 equals 1, so x is going to equal 0. Again, you have to know rules of powers, know the properties, it helps, but this one was a pretty easy one, even if you didn't. All right, let's go ahead and go to number 10. Same thing here, still, here's my base, switching these two. I'm going to end up with 10 to the power of x equals 1 over 1,000. How do I change it? To get the same base, what do I have to do first for this one? I'm going to go ahead and yes, I'm going to flip it. I have 10. Oh, thank you. It is 100, not 1,000. I thought it was 1,000, but it's 100. 10 to the power of x equals 100 to the power of what? Negative 1. Now I have to try and change it to get the same base. 10 to the power of negative 2. Go ahead and cancel out your bases. You're going to have x equals negative 2, and that is my answer. Okay, nothing too hard for that one. Let's go ahead and look at number 11. Log base 6 of 1 equals x. Again, I'm trying to solve for x. I'm going to have 6 to the power of x equals 1. And again, this one was a property.
So it's going to be 6 to the power of 0.
Anything to the power of 0 is 1, so I know x equals 0. Okay, do not write x equals 1. I'm trying to solve for x, and it's going to be 0. Don't get that mixed up. And looking at the last one on this slide, still solving the same thing. Here's my base. Switching my order, I'm going to have 5 to the power of x. 5 of x equals 1 over 125. Going ahead and trying to get the same base, what do I do first when I have that fraction? Flip it. 5x equals 125. Because I flipped it, what is my power? Negative 1. Okay, so now how can I get a base of 5 here? 5x equals, what is my power for this? Base of 5, 5 to the power of, good, it's going to be a negative 3 because I had the negative 1 before. Just multiply it times 3. Cancel out my bases. X is going to equal negative 3. Super easy for that one. All right, again, not hard. We've kind of covered all of this already. Super easy. You guys got quizzed on this. Just solving for x here. All right, looking at number 19. I like to rearrange it to where my x is going to be on the right. So I am actually going to rewrite it as, let me get a different color so we could see it. I'm going to rewrite it as white. Log base 8. Log base 8. The 4th root of 8 equals x. Okay, this is how I'm rewriting it. So how am I solving for this? I'm still doing the same process. However, we have to know some previous information from past lessons. So when I'm looking at this, radicals are the same as fractional exponents. Okay, radicals are the same as fractional exponents. So if I'm looking at the 4th root of 8, I can rewrite this using a fraction. So it looks a little pretty and something we can use. But let me just give you some examples of that. So giving you an example, if I have the square root of x, I can rewrite this using an exponent as x to the power of a half. Giving you another one, if I have the 3rd root of x, I can rewrite it as x to the power of a 3rd. So hopefully we kind of see what's going on here. Let me give you another one. If I have the 3rd root of x squared, I can rewrite it as x to the power of 2 over 3. So knowing that information, we can change this to, I'm going to change this one to log base 8 of 8 to the power of 1/4 equals x. So it looks a little better and I got rid of the radical. We're solving it the same way we've been doing for the last few questions. So here is my base. I'm taking all of this and I'm still switching that order. So now what is it going to look like? 8 to the power of x equals 8 and 1/4. Do I have the same bases here? Yes. So what am I going to do? Cancel them out. So what does x equal? 1/4. Nothing too hard. Super easy. All right, looking at number 20. Please follow along on this one. Number 20 is written in exponential form. Okay, this is written in exponential form. I want to change it. Okay, I'm going to change it to log form. So what do I have? This is my base. This is my exponent. Okay, if you want to rewrite it to where your x is on the right, you can, and I'm going to rewrite it for you. It's 3 to the power of log base 3 of 8 equals x. Now I can kind of see the switching happening. Okay, this is my base, like we said, and then I'm switching the order of my x and my exponent. Keep in mind, I'm changing it to log form. So log form, this is what it's going to look like. I have to add that log. You guys went over this before. Your base stays the same, and I'm switching the order. Okay, do we all see that? All I did was switch the order. So my x switched and my log base 3 of 8 switched. Okay, so here was that base and here was that switch. So you guys can see it a little better. Now, I can cancel out here. My log base 3, my log base 3, and I'm going to end up with x equals 8 as my answer. Again, all you have to do is know the rules. It may look funky, but just keep with it, switch what you have to, and then see what you have. All right, looking at 21. Okay, same thing here. Again, if you want to rewrite it, rewrite it. I have 2 to the power of log base 2 of 9 equals x. I have my base. I'm going to switch my order. So now I have log, because I'm switching into logarithmic form, base 2 of x equals log base 2 of 9. These can cancel out, and I'm going to have x equals 9. Just again, following that same order. All right, going to 22, looking at 22, what do I have here? Same thing, but now my x is in a different place. I have it in log form. Same thing that we've been doing. This is my base, switching it where I can solve it. So I'm going to have x to the power of negative 2 equals 25. Okay, in this case, I have to try and get the same base. Okay, I have to try and get the same base. It's up there. So, how can I get, no, not that I have to get the same base. I have to try and get the same power. Okay, I have to try and get the same exponent. So, how can I get the same exponent here? What do I have to do? How can I switch it to get a power of a negative power? How can I switch this to get a negative power?
You put it over 1.
Okay, I'm going to put it over 1, so that's one step. But how can I also get it to have a power of 2?
You do 5.
I'm going to do 5. So I have x to the power of negative 2 equals, I can get 5 to the power of 2. And like Luke said, we're going to go ahead and switch it to get a negative. So I have x to the power of negative 2 equals, now it's going to be 1/5 to the power of negative 2. Remember, in order to get a negative exponent, you have to flip it. So you could cross out your exponents, and x is going to equal 1/5. Okay, so in this case, you have to try and get the same exponent, and I'll write it on there. For this question, you have to get the same exponent. Okay, you have to try and get the same exponent to find the base. Okay, you have to try and get the same exponent to find the base for that question. So, still switching it around, it's still possible to get that same base. Don't forget to change it from a positive power. You have to flip it. to a negative power. Okay, so make sure you guys do that little flip if you're trying to get a negative, or switch it. All right, looking at 23, I'm going to rewrite it. Or, I'm not going to rewrite it because it's already written in the same form. I need to go ahead and try and solve for x. So I'm doing what I've been doing. 4 to the power of 3 equals x. Pretty easy. Just solve this one. What's 4 to the power of 3? 4 times, good. 4 and 4 is 16. 16 times 4, x is going to be 64. That was a pretty easy one. You just had to solve. And looking at the last one, this one I'm going to go ahead and rewrite. I'm going to rewrite it as log base 4. How would I write this? 16 to the power of what?
Oh,
1/3 equals x. Okay, now I'm just going to go ahead and solve. So this is my base. Switching these. Let me write this a little smaller so it doesn't look like 16 plus 1/3. It's going to be 16 1/3 up there. So I'm going to have 4 to the power of x equals 16 and the power of 1/3.
and then you do
Try and find the same base.
4 squared.
Okay, I'm going to get 4 squared. So keeping this as 4 to the power of x equals 4 squared. Keep in mind I'm multiplying 2 times 1/3. You could put it as 2 over 1, but I'll go ahead and solve it over here. 2 over 1 times 1/3 is just going to give me 2/3. So 4x equals 4 to the power of x equals 4 to the power of 2/3. Because I have the same bases, cancel it out, and x is going to equal 2/3. And that's it. Okay. Nothing new.